This is Wednesday, April 22nd, the Wednesday of our fourth week of home learning. And your test will be tomorrow, but because Mr. Wrench has told us to give you Friday to finish up all your work, it'll extend because I always give you 2 days. So you have till Monday you can work on the test as well. So you'll have Thursday and Monday to work on the test. And that will give you time to catch up on your homework, which I really want you to try to do. So here for the test review, the first question will be about SOHCAHTOA. Remember our SOHCAHTOA, which I have detailed out there. The TOA part is that tangent of A for our triangle is opposite over adjacent, TOA, and that would be A over B. The cosine is adjacent over hypotenuse, which would be B over C, and the sine of A would be opposite over hypotenuse, which would be A over C. So those are just things we wanted you to remember. So our basics. Now we have two triangles, two right triangles, 130, 60, 90. Remember the short side opposite the 30 is 1, and the hypotenuse is twice the short side, and the long side opposite the 60 is the square root of 3 times the short side, so it's a square root of 3. Now for the 45, 45, 90 triangle, both sides are 1, and the hypotenuse is square root of 2. So we'll ask questions off those triangles. So sine of 30 from our triangle is opposite over hypotenuse, or simply 1 over 2. Cosine 45 on the second triangle is adjacent over hypotenuse, and we can use either triangle, and that's 1 over the square root of 2, which we have to multiply by the square root of 2 over the square root of 2 to clear out the square root of 2 on the bottom, which gives us square root of 2 over 2. Now tangent of 60, looking at it from the top angle, is opposite over adjacent is square root of 3 over 1, or square root of 3. Now for problem 3, we have a right triangle with a base of 9 and a height of 18. So the measure of angle E, to find E, we can say the tangent of E, the top angle, is opposite over adjacent, or 9 over 18, which is a half again. But E, remember, is the tangent inverse of 0.5, which to 1 decimal point is 26.6. Make sure your mode is in degrees. Now to find the measure of D, we can just say 90 minus 26.6 is 63.9, because those D and E add up to 90, along with F being 90. Now to find DE, the hypotenuse, it's just our right triangle theorem. 9 squared plus 18 squared is the square root of 81 plus 324, square root of 405, which is approximately 20.1. Now to find the area to the nearest square foot of the regular octagon, remember n equals 8, with center D and side 10. So I'm just showing the bottom of the 8 triangles. There'd be 8 triangles all around, and each angle would be, for the whole triangle at the top, would be 360 over 8, dividing it evenly would be 45. And as we've done before, we take half of that to work on half of the triangle. So half of the side of side 10 would be 5. So for our little triangle, that's the bottom of the 8 triangles. We have on the right triangle, we have 5 for a side, A, the apothem for the altitude, and 22.5 for the angle up top. So we can use the tangent of 22.5 to be 5 over the apothem, and then cross multiplying the apothem times tangent 22.5 equals 5, dividing both sides by tangent 22.5 leaves us with the apothem as 5 over 22.5. Now we've seen when we calculate area, we leave the apothem without getting a number for it because it leaves it more accurate for the final answer. So remember, the area is equal to 1/2 the apothem times the perimeter, which is 0.5, and then what we found for the apothem, 5 over tangent 22.5, and then the perimeter is 8 sides of 10, So multiplying the top numbers, 200 over tangent 22.5, or to the nearest foot as it asked, square foot, 483 square feet. On problem 5, we have state the magnitude and direction of the vector -4, 6 to the nearest tenth. So notice we're going 4 to the left and up 6, and our alpha is as shown. So the hypotenuse, which is what we're really finding in the vectors, is the square root of 4 squared plus 6 squared, which is 16 plus 36, or the square root of 52, which is approximately 7.2. And the alpha, the direction angle, is tangent inverse of 6 over 4, which that comes out to tangent inverse of 6 over 4 is 56.3. So remember, the way we did this in 12.4 was the vector v is a magnitude 7.2 at 56.3 degrees above the x-axis. And that's why we don't put -4 there, because we identified as being negative above the negative x-axis. Now 6 is an easy one. Match each trig ratio. Cotangent is 1 over tangent, and remember that tangent was sine over cosine, and so 1 over tangent is the reciprocal of that, or cosine over sine. Secant is 1 over cosine, one of our basic reciprocals. Cosecant is 1 over sine. Those are our 3 basic reciprocals: cotangent, secant, and cosecant. And then tangent is reciprocal of cotangent, which is just sine over cosine. And we've done all those before. Now in 7, we're going to use the law of cosines to find k, the side opposite angle 48, the way law of cosines, the SAS form, works, to the nearest tenth. So k squared is equal to the given sides j squared plus l squared minus 2jl cosine k. So the side k squared is equal to 75 squared plus 42 squared minus 2 times 75 times 42 times the angle opposite cosine 48, which comes out to 3173.48, and the square root of that comes out to about 56.3 to the nearest tenth. Now on problem 8, we have a right triangle with sides of 6 and 10, and if we calculate the hypotenuse on that, we get DE is the square root of 6 squared plus 10 squared, or 36 plus 100. Square root of 136 is 11.66. So now we're asked to make comparisons. So first we're going to get the cosines and sines of and tangents of all D and E. So the cosine of D is adjacent over hypotenuse, or 6 over 11.66, which is 0.51. Sine of D at the top is opposite over hypotenuse, or 10 over 11.66, which is 0.86. Now notice cosine E is the same as sine D, and sine E is the same as cosine D. That always happens. And so tangent D is opposite over adjacent, which is 10 over 6, or 5 over 3, which is 1.67. And tangent E from the right, is 6 over 10, or 0.6. Now we're asked to compare cosine D, which is 0.51, to sine D, which is 0.86, and clearly it's less than. We're looking at sine D, 0.86, compared to sine E, which is 0.51, so that's a greater than. Now sine D is equal to cosine E, as we said, and tangent D, 1.67, is clearly greater than tangent E of 0.6. Now sine E divided by 6, if you look, is 6 divided by 6 divided by 11.66. So sine of E divided by 6 is just 1 over 11.66. And sine D over 10, see the 10s cancel. When you divide sine D by 10, the 10s cancel, and you're left with 1 over 11.66, which is equal. So the two are equal. Now 9, to find the area of a triangular garden with sides of 10, 13, and 14, we use the SSS theorem for getting area, which is also called the Heron's theorem. He was the Greek guy. So we get the semi or half perimeter of 1/2 times the sum of the sides, 10 plus 13 plus 14, or 1/2 of 37, which is 18.5. And the area formula now is square root of 18.5 parentheses 18.5 minus 10. We do that with each side. 18.5 minus 13 and 18.5 minus 14. Or the square root of 18.5 times 8.5 times 5.5 times 4.5, which is approximately 62 square yards. Now for 10, it asks us to find the resultant of 2u plus v if u is 3, negative 2, and v is negative 2, 5. Well, as you see there, I can do 2 times the vector 3, negative 2 is 6, negative 4, plus negative 2, 5. So we can add x components and add y components. And doing that, we get 6 minus 2 for the x component of 4, and negative 4 plus 5 for the y component of 1. Now notice how I've drawn the graph. I've drawn v once as right 3 down 2, and then v again for the 2v, which ends up at 6, negative 4. And then to add the v, negative 2, 5, I go from 6 back to 4, and then I go up 5 from negative 4 to 1. So that's why the resultant vector 4, 1 ends up there at 4, 1, where 2u plus v are from my graph. Now for 11, prove that secant squared times 1 minus sine squared equals 1. Well, remembering this, it's been a little while, but sine squared plus cosine squared equals 1 is our fundamental identity. And when we subtract sine squared from both sides, we get what we want here, which is cosine squared equals 1 minus sine squared, which I can substitute for the 1 minus sine squared above, and get secant squared times cosine squared, which are reciprocals of each other. So secant squared is 1 over cosine squared times cosine squared equals the 1 that we were asked to demonstrate. Now for 12, we use the law of sines to find PQ to the nearest tenth, and we're given that angle P is 69 and angle R is 54 and PR is 22, which gives us an ASA triangle, 2 angles with the side between, which is definitely for law of sines. So now we need to find angle Q to get the side we need. So we can say angle Q is 180 minus the 2 angles that we were given, minus 69 minus 54 is 57. So now PQ, the side we want, over the sine of the angle opposite, over sine 54, is 22 over the sine of the angle we just found, 57, angle Q. So cross multiplying, PQ is 22 sine 54 over sine 57, and that comes out to approximately 21. Now on 13, we have a simple problem that works, tangent works best for. So we have a height of A and a top of 150 and an angle, it's a right triangle, and the angle there is 25. So tangent of 25 is the opposite over adjacent, which is what we have, so that's A over 150. So we can cross multiply, and A equals 150 tangent 25, approximately 7 feet. Now for 14, it says use the SAS theorem to find the area to the nearest square kilometer. Well, we have side AB is 70 kilometers, side AC is 180 kilometers, and the angle between them to make it SAS is 45. And remember, our simple formula for area for that is 1/2 times the sides times the sine of the angle between. So it's 1/2 BC sine A, which gives us 1/2 times 70 times 80 times sine 45, which to the nearest whole number is 4455 kilometers squared. For 15, we want to prove that secant minus sine tangent is equal to cosine. Well, secant is 1 over cosine, and tangent is sine over cosine. So we have 1 minus sine squared over the common denominator cosine squared, giving us, as we just saw earlier, cosine, 1 minus sine squared is cosine squared from our fundamental identity, over cosine, and one of the cosines cancels, leaving us with just cosine, which is what they asked us to show. Now on 16, it says to use the law of cosines. Here we have all sides given to find angle T to the nearest tenth of a degree. So finding for the angle, remember, is the two sides that we don't have the angle for, r squared plus s squared, minus the side opposite the angle we're trying to find, t. So r squared plus s squared minus t squared over 2rs, and plugging in our numbers, r is 9, and s is 8, and t is 5. So 9 squared plus 8 squared minus 5 squared. Remember, we do hit enter. We have to do it that way and get a number so we can divide, and it'll come up with a and s divide, parentheses 2 times 9 times 8, hit enter, and that will come out with 0.8333 roughly. So then we have to get, that's just the cosine of t, but we want t, so we have to get the cosine inverse, second cosine, of 0.8333, and to 1/10 is asked for, that's 33.6 degrees. Now on 17, we have another tangent equation, because see, the height of the right triangle is h, the base is 200, and the angle is 68, and that works for the tangent. So tangent of 68 is h over 200, and cross multiplying, h is 200 tangent 68, which to the nearest whole number is 495. Now on 18, we're asked to prove our fundamental identity, to show that sine squared plus cosine squared equals 1 on our ABC triangle, with angle A being designated as x. So we can say that sine x is opposite over hypotenuse, A over C. Cosine x is adjacent over hypotenuse, B over C. And sine squared plus cosine squared then, using our triangle, is A over C squared plus B over C squared, which is A squared over C squared plus B squared over C squared, which is A squared plus B squared, and from our hypotenuse theorem, A squared plus B squared is C squared, so we end up, as we have to, with C squared over C squared equals 1. Now in 19, it says use the SAS theorem to derive the law of sines. Well, the SAS theorem is to have 1/2 times 2 sides times the sine of the angle between them, and here's the 3 cases. A equals 1/2 BC sine A equals 1/2 AC sine B equals 1/2 AB sine C. And if we divide all 3 of them by 1/2 ABC, you can see on the first, the halves cancel, the BC's cancel, so I'm left with sine A over A. On the second equality, I have the half canceling again, and the A and C canceling, so I have sine B over B. And on the last, I have the half and the A and the AB canceling, leaving sine C over C. And that is indeed the law of sine. Sine A over A equals sine B over B equals sine C over the side opposite C. Now the last one is a little bit more involved word problem. So what we have, we're using directions here. So we're given that from point B is our starting point, which will be our origin, and we're being told that we're going 45 degrees west to the left of south, 3 miles per hour. So that's why we go from B down to C with a 45 angle degree, because it's west of south, and then inside the triangle to the x-axis is also 45 degrees. Okay, and so then we have another one going, let me see. So we have we have 17 miles per hour, and that's at a right angle to our BC. And so now we have that angle B is 80 degrees. We're told that. So what we can say is that angle B is the known 45 direction plus the alpha that we're trying to find. And so tangent B now, because we're told that 17 miles per hour makes a right angle with the 3 mile per hour, which was the BC. So we can say that tangent B is the opposite over the adjacent, or 17 over 3. B is equal to inverse tangent 17 over 3, or 80. So that allows us to find the alpha, which is now B minus 45, or 80 minus 45, or 35. So, and that 35 is up north from left west, so that's 35 degrees north of west is our final resultant vector from B to E. Now our R squared resultant vector is the square root of 17 squared plus 3 squared, like always for a right triangle, and that comes out to 289 plus 9, so it's the square root of 298. But we're also told that there was 8 hours of time that elapsed, so we have to use the fact that distance equals rate times time, and after 8 hours, our resultant hypotenuse BE is 8 hours times the distance square root of 298, which multiplies out to distance of 138 miles to the nearest tenth at the alpha 35 degrees north of west. Now, as I said, you'll have plenty of time to work on your test. You'll have Thursday, Friday, the weekend, and Monday. So use that to catch up on your homework. And this is the end of all of our regular chapters. All we have left is catching up on the homework and the final. So God bless you. You've done very well. Keep up the great work. I really appreciate it.